And we're going to do an example here. Okay. For this example, it's for analyzing the calcium content in urine. And this includes 2 steps. The first one is standardization of the titrant. The second one is analysis of the unknown. Okay, so how does this work? The calcium content of urine can be determined by the following procedure. First of all, you will precipitate calcium with oxalate in basic solution. Okay, you will form this oxalate, and then you will wash the precipitate with ice cold water to remove free oxalate and dissolve the solid in acid to obtain calcium and oxalic acid in solution. Okay, so basically you add oxalate into the urine sample first to precipitate all the calcium, and then this calcium precipitate will be processed, like removing the free oxalate, and then you will dissolve them again in acid to obtain the calcium and the oxalic acid. So all the oxalate you have used here to consume calcium will be converted back to oxalic acid. And then you will heat the solution to 60 degrees and titrate the oxalate with standardized potassium. Okay, pay attention here. We have a term, standardized potassium. Potassium permanganate, okay, until the purple endpoint of reaction 7-1 is obtained. So this is the reaction 7-1. We know that potassium permanganate should be purple color, but when you have oxalate in the solution, all the potassium permanganate will be reacting with this and convert to manganese 2+. So during the reaction, you won't be able to see any purple color. But once the oxalate has been completely consumed, you will have excess amount of permanganate in your solution. That's the moment you started to see purple color. Okay, and that is also your endpoint. All right, so that is the idea of how this is done. And again, for if you have an unknown urine sample, you have a urine sample with unknown calcium amount, you will carry out all the steps to determine the amount of calcium in the urine. And before you actually test the unknown, you have to make sure that you know the concentration of the potassium permanganate, okay? And that is what we do here. The first step is called standardization. So we want to use a primary standard to determine the concentration of potassium permanganate. And here we're using sodium oxalate. Okay, if you recall the table I just showed you, sodium oxalate is on the table of the primary standard, okay? All right, so we have this. We use this and dissolve in a 250 milliliter volumetric flask. And if 10 milliliter of this solution requires 48.36 milliliter of permanganate solution for titration, what is the molarity of the permanganate solution? Okay. Before we're doing the calculation, let's look at the, let's go back and look at the stoichiometric ratio. For oxalate and permanganate, it's 5:2 ratio, okay? So for every 5 mole of oxalate, it reacts with 2 mole of permanganate. Okay, let's remember this number. And going back here, basically for titration, we're using the moles of titrant to determine the moles of the analyte and then calculate the concentration of the analyte, right? So first of all, how do we get the moles of sodium oxalate used in this reaction?
Find the moles of the sodium oxalate and then use mole ratio to find the oxalate alone.
What do you mean by mole ratio? You mean, okay. So you
There's
mean the mole
one.
ratio in this
Yeah.
compound? Okay. So we have 0.3562 gram of sodium oxalate, and because of the formula weight is 134 gram per mole, we can calculate the moles of sodium oxalate. And basically, 1 mole of sodium oxalate has 1 mole of oxalate, right? It's 1-to-1 ratio. So by doing this, what you have is the moles of oxalate in 250 milliliter solution. Okay. But did we use all the 250 from the solution? We didn't, right? We only used 10 milliliter of the solution. Does that make sense? So we will use 250, 10 milliliter over 250, because this is from 250 and you only took 10 milliliter from it. So you will do it this way. Or in another, or if you think it as a different thing, you can think about this whole thing, right? The moles divided by 250, this is actually the concentration of oxalate. And then you multiply this concentration by 10 milliliter to get the moles of oxalate in this 10 milliliter solution, right? Does that make sense? But anyway, so everything we did here, it gives us the moles of oxalate in 10 milliliter solution, right? And we need to figure out how many moles of permanganate is reacted here. And still remember the ratio? It's 5. Oops. It's 5 oxalate react with 2 permanganate, right? And because this part is the moles of oxalate, so we need to multiply by 5 oxalate. For every 5 is 2 permanganate. And after doing this, we will get the moles of permanganate, right? And eventually we want to look for the molarity. Once you get the moles, you will divide the moles by the volume, right? Which is 48.636 milliliter. And for molarity, we want liter. So it will be 1,000 liter, 1,000 milliliter over 1 liter. Okay, let's try to get the answer here. What is the concentration of the permanganate solution?
Professor,
Yes?
I had a question. So on the top it says 0.3562, and the 2 is a little apart from the 6. Is that supposed to be a subscript or?
I don't think so. Sometimes when people are writing numbers, they put every 3 numbers in a group because it's easier to tell that after that it will be milligram, right?
Yeah.
It's like when you're writing the large numbers like this, you will write it this way.
Yeah.
It's just for clarification.
Okay, thank you.
No problem. Okay.
Professor, I had a quick question.
Mm-hmm.
How do we know that the mole ratio of sodium oxalate and oxalate was 1:1?
When you're looking at the formula here, 1 mole of sodium oxalate, you only have 1 mole of
Oh,
oxalate, right?
I see it.
Mm-hmm. And so it's 8.795 times 10 to the -4 mole per liter.